Hey guys, so today I'm going to be explaining the 555 constructional block diagram and how easily you can learn it. So first of all, the 555 IC has 8 pins, of which let me just list them out for you. Let's say this is the IC. Yeah, so we have 1 2 3 4 5 6 7 8. The first one is the ground, 8 is VCC, 4 is reset, second is the trigger, 3 is the output, 5 is the control voltage, 6 is the threshold, and finally 7 is the discharge. So keeping these in mind, let's draw the constructional block diagram. So let me just take this here. Yeah, so first of all, since it's 555, it says in the name, it means there are 3 5k resistors in series in order to form a voltage divider. So if we just go down a little bit here, yeah, so let's just draw 3 5k resistors in series, 1 2 and 3, one more. So here at the top you can mark this as VCC, which is pin number 8. Now, and down here, let's take a different color. This is the ground. So this is the ground, which is pin number 1. Okay, now let's get into the rest of it. Now we're gonna have 2 comparators, op amps. So one comparator here and one comparator here. Non-inverting terminal, inverting, non-inverting, inverting. Okay, now let's start from the below one. So here, first of all, let's write this 5k, 5k and 5k. So down here, the inverting terminal of the lower comparator, and this is the upper comparator. The lower comparator's inverting terminal is our trigger, which is pin number 2. The upper is just shorted here, connected to 1/3 of the VCC. As you can see, from this point to this point, there's going to be across this one resistor, so it's going to be 1/3 of VCC. Okay, so shorted there, and the lower one of this upper comparator, the inverting terminal, is shorted here, and additionally it comes out. This is the control voltage pin, which is pin number 5, which we can set according to what we want, or generally we leave it hanging like that. Okay, and the non-inverting terminal is the pin number 6, which is the threshold, pin number 6. Okay, so here this left part is done. Now what we need is a SR latch. So here we take this is just a representation of a SR latch. This is the set input, this is the reset input, this is the output, and this is the complemented output. So here we use the complemented output. So we give the set input to the lower comparator's output and the reset input from the upper comparator's output, and let's take this inverted output and we give it to 3 different places. Starting with the first one, we give it here, again a representational diagram of a inverted power amplifier. So we need to amplify the output. So here this is going to be our final output, where we are going to get the square pulses, depending on whether we design it to be a monostable, astable or bistable multivibrator. But here we're going to get the output. So this is the output, which is pin number 3. And additionally we give it here to a PNP BJT transistor. So this is the emitter, this is the collector, this will be connected here, and this one's will be getting its source from a reference voltage which will be given, and it's controlled at the base via the reset pin, which is the pin number 5. Okay, so this is a PNP transistor, as you can see. And finally it is also given here to another transistor, another BJT, but here it's going to be a NPN transistor. So this is the emitter, and the emitter is going to be grounded permanently, and the collector is going to come out here, and it's going to be our pin number 7, which is the discharge. Okay, and this is the base, which is going to come from the output of the SR latch. So this is a NPN transistor, and as you can see, this is done. This is the final block diagram. Let's see if we covered all the pins. We have the pin number 1, which is ground, so this is done. We have trigger, which is here, this is done. We have the output here, which is also done. We have reset, which is done. Control voltage here, done. Threshold here, discharge, and finally VCC. So this is a simple way of drawing the 555 constructional block diagram. Thank you.